Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 physics get more than 95% marks series. Today's chapter is alternating current, chapter 7 ncert line by line, part 5. Before we begin our class, we request you to subscribe our channel if you have not done yet. Please like and share our videos among your friends and relatives so that they will also get benefited of that. And please click on the bell icon so that you can get automatic notification whenever a new video is uploaded by us, so that you won't miss any of our important videos and updates. Let us begin today's class. In the last class, we have done the LCER circuit and we have derived various expressions for current, voltage, potential difference, etc., root mean square velocity, and others for LCER circuit. Today, we'll continue with that and start with a new topic that is called resonance. An interesting characteristic of the series LCR circuit is the phenomena of resonance. The phenomena of resonance is common among systems that have a tendency to oscillate at a particular frequency. This frequency is called system's natural frequency. If such a system is driven by an energy source at a frequency that is near to the natural frequency, the amplitude of oscillation is found to be large. Uh, Means, say a system has a frequency neta and some energy source is there, and this, which is also producing a frequency that is, say, delta. Delta is approximately equal to neta, its natural frequency. Then at that case, amplitude is maximum. They want to say by these lines. Again, let us read it. If such a system is driven by an energy source at a frequency that is near the natural frequency, the amplitude of oscillation is found to be large. A familiar example of this phenomena is a child on a swing. The swing has a natural frequency for swinging back and forth like a pendulum. If the child pulls on the rope at a regular interval and the frequency of pull is almost same as the frequency of swinging, the amplitude of the swinging will be large. For a LCR driven circuit, for a LCR circuit, for an LCR circuit, or for a LCR circuit driven with voltage of amplitude Vm and frequency omega, we found that current amplitude is given by Im is equal to Vm by Z. We have done this in our last session. Please go through the previous video to get the details. So Vm, we will keep Vm as Vm. but z we can put under root r square plus xc minus xl whole square. This also we have done in the last video. With xc is equal to 1 by omega c. So xc is equal to 1 by omega c and xl is equal to omega l. So if omega is varied, then at a particular frequency omega naught xc is xc minus xl, the impedance is maximum, that is z is equal to r. So at a particular frequency omega, xc is equal to xl. So let me explain it properly in a separate easier way. So in the last session we have derived an expression that is I is equal to Im sine omega t plus phi, and equation number you can see in your book was 7.34, and we have written Im, we have told where Im is equal to Vm upon Z. Again we have told that Vm upon putting the value of Z, that is r square plus xc minus xl bracket square, and this was called equation 7.34a. Continuing from here, we'll derive and we'll try to understand for the resonance. Again we told that we have derived that xc was equal to 1 upon omega c and xl was equal to omega l. So these things we have already seen in our last class. Now for resonance, if omega is varied, so in this case if omega is varied means it is changing, then a particular frequency omega naught, so at particular frequency omega naught, at a particular frequency omega naught xc is equal to xl and the impedance is minimum. So Xc is equal to XL, and impedance and the impedance is minimum. Minimum. That is, impedance Z is equal to under root R square plus, here Xc is equal to Xc, and instead of XL, here see this equation here. So Xc will write Xc, and instead of XL we can write Xc. Why? Because Xc is equal to XL. So here we'll write Xc minus Xc whole square. That means Z is equal to R square plus, this is 0, Xc minus Xc is 0 whole square, that is 0. Therefore Z is equal to R. This frequency is called resonant frequency. So this frequency this frequency is called resonant frequency. 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 So which frequency? The omega naught. This frequency is called resonant frequency. Now Xc is equal to XL. So let us continue with Xc at resonant frequency. Xc is equal to XL, or we can write Xc's value is 1 by omega naught C, and XL's value is omega naught L. Therefore we can write, or we can write 1 upon LC, and this omega naught goes this side, L comes this side in numerator, so we got omega naught square. Or we can write omega naught square is equal to 1 upon LC. Therefore we can write omega naught is equal to 1 upon under root LC. And this is equation 7.35 in your book. So till here it is clear? You are with me now? Now let us see your book to see the graph and few more details. So we have explained till equation 7.35. At resonant frequency, the current amplitude is maximum. That is, Im is equal to Vm upon R. Figure 7.16 shows the variation of Im with omega in LCR series circuit with L is equal to 1, mH, C is equal to 1, NF, and two values of R1 is equal to, one value is 100 ohm and second value is 200 ohm. For the source applied Vm is equal to 100 volt. Omega naught for this case is 1 upon under root LC, that is omega naught's value is this much, 1 into 10 to the power 6 radian per second. So in the graph they have explained, so variation of Im with omega for the two case, R is equal to 100 ohm and R is equal to 200 ohm, L is equal to 1 mH. We see the current amplitude is maximum at resonant frequency. So current amplitude is maximum at resonant frequency. Since Im is equal to Vm upon R at resonance, the current amplitude for case 1 is twice to that of case 2. Why? You see, in this case, first resistance is R is equal to 100. Second resistance is R is equal to 200. So the formula is Im is equal to Vm by R. In this case, Vm is constant. So Im will depend upon the value of R. So in the first case, if Im is Vm upon 100, and in the second case, so case 1, and the second case, Im is equal to Vm upon 200, then 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 if we divide 1 by 2, what we'll get? Im case 1 upon Im case 2 is equal to Vm by 100 upon Vm by 200. So automatically we'll get Im case 1 Im case 2 is equal to 2. 2. So if we cancel it, Vm get cancelled, this get 2, this has got 1, 2 will go at the numerator. So ultimately we got, what we got? Im1, the case 1 is twice than Im of case 2. So here it is written the same. What is written? If we see the current amplitude is maximum, we see the current amplitude is maximum at resonant frequency. Since Im is equal to Vm by R at resonance, the current amplitude for case 1 is twice to that of case 2. Here case 1 is twice 2 multiplied by that of case 2. So the hidden meaning of this line, how we reach to this conclusion in this case, in this whole case, is this is the derivation. Now resonant circuit have a variety of application. For example, in the tuning mechanism of a radio or a TV set. So these are the what they are telling, resonating circuit, what is the uh, benefits, what are the uses. The antenna of the radio accepts signals from many broadcasting stations. The signal picked up in the antenna acts as a source in the tuning circuit of the radio, so the circuit can be driven at many frequencies. But to hear one particular radio station, we tune the radio. In tuning, we vary the capacitance of the capacitor in the tuning circuit such that the resonant frequency of the circuit becomes nearly equal to the frequency of the radio signal received. When this happens, the amplitude of the current with the frequency of the signal of a particular radio station in the circuit is maximum. So this is one of the important question which can be asked. So let me go to the details. In have everyone have a radio, and radio antenna. Initially 10 years back, 20 years back, we use radio antenna or TV antenna. That antenna catches the frequency of all the stations, TV stations or radio stations. So we are taking two separate cases. For radio, we'll just consider radio. Don't get confused with radio and TV together. No, radio is a separate thing. So let us discuss for radio first. So in 30 years back, we have radio antenna also, or we have a radial or in the radio. So we pull that aerial. So that aerial catches frequency from many radio stations, but user need to hear only one radio station. In that, what user does, they tune the radio, and while tuning, what happens, the frequency is same as that of the frequency of the radio station. How it happens? By varying the capacitance of the capacitor. While tuning, what is happening? It is varying the capacitor of the capacitance such that the resonant frequency of the circuit becomes equal to the frequency of the radio signal received. So this is the main thing what is happening. In tuning, we vary the capacitance of the capacitor in the tuning circuit such that the resonant frequency of the circuit becomes nearly equal to the frequency of the radio signal received. When this happens, the amplitude of the current with the frequency of the signal of a particular radio station in the circuit is maximum. In this way, you can see here that station. Now, it is important, same thing happens in TV also. It is important to note that resonance phenomena is exhibited by a circuit only if both L and C represent in the circuit. Only then do the voltage across L and C cancels each other, both being out of phase, and the current amplitude is Vm by R, the total source voltage appearing across R. This means that we cannot have resonance in a RL or RC circuit. Remember, this is also very important. So it is important to note that resonance phenomena exhibit only in where we have LC circuit. Only then do the voltage across the L and C cancel each other, and the current amplitude Vm upon R. the total source voltage appearing across R. This means we cannot have resonance at LR circuit, neither at RC circuit. Sharpness of resonance. The amplitude of the current in LCR circuit is given by Im is equal to Vm upon under root R square plus omega L minus 1 by omega C whole square, and is maximum when omega is equal to omega naught 1 upon under root LC. The maximum value. So this we have already done. We have already done this in the last video, and is maximum when omega is equal to omega naught and is equal to, which is equal to 1 by under root LC. In the last expression we have done, the maximum value is Im max is equal to Vm upon R. For the value omega other than omega naught, the amplitude of the current is less than the maximum value. Suppose we choose a value of omega for which the current amplitude is 1 by root 2 times maximum times its maximum value. At this value, the power dissipated by the circuit becomes half. From the curve in figure 7.16, we see that there are two such values omega and say of omega, say omega 1 and omega 2, one greater than other, one greater and the other smaller than omega naught. The symmetrical about omega naught. We may write omega 1 is equal to omega naught plus delta omega, and omega 2 is equal to omega naught minus delta omega. So from the curve in the figure 7.16, which is here, we have considered the two values of omega. Two values of omega. One is greater than omega naught and other is smaller than omega naught. So let us see. So we can write it. We can write omega 1, which is greater than omega naught. How much greater than omega naught? Say delta omega. Omega 2, which is smaller than omega naught. How much smaller than omega naught? Delta omega. So delta omega less than omega naught. So these are the two values of omega 1 and omega 2. The difference of omega 1 and omega 2 is, so just subtract it. What is the difference? Difference is 2 delta omega is often called bandwidth. So difference is often called bandwidth. Bandwidth of the circuit. The quantity omega naught upon 2 delta. So the quantity omega naught upon 2 delta omega is regarded as a measure of sharpness of resonance. So this is regarded as a sharpness of resonance. This is regarded as sharpness of resonance. The smaller the delta omega, the sharper or narrower is the resonance. So the smaller the delta omega, then the resonance, then the resonance will be will be sharper, sharper or narrower, same thing. To get the expression for delta omega, we note that the current amplitude Im is, so we have to find out delta omega, an expression for delta omega. We can write bracket 1 by root 2 Im max for omega 1 is equal to omega plus omega naught plus delta omega. Therefore, therefore at omega 1, at omega 1, Im will be equal to Vm upon under root r square plus omega 1 L minus 1 by omega 1 C. Now we can write but there is a relation for I m max, which we have seen in the last in this class only, few minutes back. So Im by root 2 is equal to Vm by r root 2. Putting this relation here, we can get Im. So for W1, we have Im max by root 2. So just instead of this for W1, for W1 omega 1, so we can write this, and instead of this we can write Vm r root 2 is equal to Vm under root r square plus omega L minus omega 1 C. Now Vm got cancelled, so we can write now cross multiply, we can write under root r square plus omega 1 L minus 1 by omega 1 C is equal to r root 2. Now, squaring both the sides, we get squaring both the sides. What we get? This side only this much is left, and this side if we square we got r square, 2r square is left. Now omega 1 L minus 1 by omega 1 C is equal to 2r square, and this r will go this side, so it will be minus, this was plus, this side it will come minus. So we have omega 1 L minus 1 by omega 1 C is equal to r, 2r square, that is r square. Uh, we have made the square here. There's a square, so there is a square here, there was a square here, so we can write 1 by omega 1 C is equal to r. We got a today's derivation. Now we'll put omega 1 as omega 1 is equal to omega naught plus delta omega. Where we'll put this in this equation. So what we'll get? Wherever we see omega 1, we'll put omega naught plus delta omega, because omega 1's value is omega naught plus delta omega. So omega naught plus delta omega L minus omega naught plus delta omega C is equal to R. So we can write now. Now what we'll do? We'll take omega naught common from here. What will take omega naught common? So omega naught, L is already here, so L is, so what is left here? If we take omega naught from this whole, what is left here? 1 is left here. If we take omega naught from here, there is no omega naught, so in the denominator there will be a omega naught. Any question till here? L is already here, so we have written L here. We have taken omega naught common from this and this, so omega naught common from this gives 1, and there is no omega naught here, so omega naught, 1 omega naught will come in the denominator. Now minus, in the same way we'll take omega naught common from here. So C is already here, so we can write omega naught C. So if we take omega naught common from here, 1 is left. If we take omega naught common from here, not, there is no omega naught, so it will come on the denominator, and this is the value we got. Now in the next step, we know that omega naught square is equal to 1 by LC. So this is the relation we know. We'll use this relation in this equation. How to use it? Let us see. So what we'll do here, this step will remain as it is, just we'll copy it. 1 plus omega delta omega omega naught. The changes will come in this step. What changes? We'll multiply and divide by omega naught. We can do it. So multiply by omega naught. The numerator was 1, so it is multiplied, so it is now omega naught. Now omega naught dividing by omega naught, already one omega naught is there, so omega naught square. C is already there, rest of the thing we will copy as it is. Good. Now is equal to R. Now we'll copy as it is the first step, there is no change. In the second step, we'll implement this formula for omega naught square. So we'll write as it is. For omega naught square, we can write LC. So multiply by C, 1 plus delta omega, omega naught is equal to R. So C get cancelled and L will 1 upon, so L will come here in the numerator. So omega naught L 1 plus delta omega, omega naught minus omega naught L 1 plus delta omega upon omega naught is equal to R. So hope this is clear to you. The catch step is multiply and divide by omega naught. And as soon as you do it and implement this omega naught square is equal to 1 upon LC, you can easily derive to this equation, Now, once you are here, we can approximate, 1 plus, so let us see. So we can write for binomial theorem, from binomial theorem, if this minus 1. So we are talking about this value. If we take this to the numerator, so this will convert it to minus 1 or inverse. And we can write this as 1 minus delta omega upon omega naught. Since, why we can write it? Since delta omega and omega naught's value is far less than 1. Therefore, we can write it. For smaller values of delta omega and omega upon omega, we can write minus, because it becomes this power. Power is comes here. 1 minus delta omega upon omega naught. So this is mathematically proved in binomial theorem. So we can write it. So now this equation can be written as omega naught L 1 plus delta omega, omega naught, no change in the first step, but there's a change in the second step, that is omega L, this whole went upside, so this can be written as this in the numerator. So 1 minus delta omega upon omega naught is equal to R. Upon solving, if you solve it, this whole equation, what you will get? You will get omega L multiplied by 2 delta omega upon omega naught is equal to R. This value you will get. Let me explain you how we will get this. So fine, how we'll get this from here. So explanation is, what we can take common from here and here. this one and this. So this one we can take common. What is left here? This whole is left here. 1 plus delta omega upon omega naught. So right under square bracket, it will be much. So already you have taken common. What is left here? Minus 1 minus delta omega upon omega naught. Correct? This whole equation can be converted into this. Now omega naught L 1 plus delta omega upon omega naught minus 1 plus delta omega upon omega naught. So this minus, what we have done, just we have multiplied by minus, nothing else. So minus multiplied by plus 1, that is minus 1, minus multiplied by minus delta omega upon omega naught, that is plus delta omega upon omega naught. So plus 1 minus 1 get cancelled. So what left here? Omega naught L multiply by what left here? So delta omega upon omega naught plus delta omega upon the omega naught, that is 2 delta omega upon omega naught. So same thing we have written here. Same thing we have written here. So is it clear now how we got this value? Good. So we can cancel omega naught, omega naught. So what is left here are 2L delta omega is equal to R. So delta omega is equal to R by 2L, and this is the equation from your book 7.36a. So this is the equation 7.36a. You will find it in your book. Now the sharpness of resonance is given by. So now let us talk about the sharpness. The sharpness of resonance is omega naught upon 2 delta omega is equal to omega naught L by R. So sharpness is given by this ratio, and upon solving we get this. How we solve this one? How we got this? So let us see. Omega naught will write as it is. To delta omega will put this value for delta omega. So R by 2L. 2 gets cancelled and we get omega naught L upon R. So we derived to this expression for sharpness. Now this is equation 7.36b from your book. Now the ratio of omega naught L upon R is also called quality factor. quality factor, that is also denoted by Q of the circuit. These are very important questions. What is quality factor, resonance, etc. So please pay attention and make a note, proper note from this tutorial, video tutorial, and try to do the practice for this derivations to get the full marks. So Q is equal to omega naught L by R. So this is known as the quality factor of a circuit, and this equation is also called 7.36 C from your book. From equation 7.36 B and 7.36 C, we see that 2 delta omega is equal to omega naught Q. So from equation 7.36 B and 7.36 C, what we see, we can write 7.36 B, we can write here omega naught upon 2 delta omega. Fine. So omega naught upon 2 delta omega is equal to omega naught L by R, and again omega naught L by R is equal to Q. So this is equation number 7.36 B, and this one is equation number 7.36 C. From these two equations, we can say that this one is equal to Q. If this is equal to this and this is equal to Q, then we can say this is equal to Q. So we can write omega naught upon 2 delta omega is equal to Q. Fine. Next, if which implies that we can write 2 delta omega. So Q multiplied by 2 delta omega is equal to omega naught. Therefore, we can write 2 delta omega is equal to omega naught upon Q. So this is an important relationship. From this, we can find out, or we can say, we can come up to the few conclusions. Larger the value of Q, larger the value of Q, so Q is in denominator. If the value of Q is larger, this value will be smaller. So simple thing, smaller will be the value of 2 delta omega. 2 delta omega is also called bandwidth. Just now we have learned few minutes back bandwidth. So larger the value of Q, smaller the value of bandwidth. Bandwidth and sharper is the resonance. And sharper is the resonance. So larger the value of Q, that is qualitative factor, smaller is the value of 2 delta omega, that is bandwidth, and sharper is the resonance. This is the condition we can set up. Now we know omega naught square is equal to 1 by LC. So from this equation, we can derive omega Q is equal to 1 upon omega naught CR. So how we got this value? Let us see. Q is equal to omega naught L. Q is equal to omega naught L by R. Where we get this equation from? Just now, few minutes back, you see this. Q is equal to omega naught L by R. Equation 7.36c. So we can write, we can multiply and divide by omega naught in the numerator and denominator. So we got this. Instead of omega naught square, we can write what we can write. We can write 1 upon LC, 1 upon LC. So 1 upon L and LC, 1 upon LC multiply by omega naught R. So L get cancelled. So we have 1 upon C omega naught R. So we have written this equation only, we have derived here. Q is equal to 1 upon omega naught RC. This is also a relation. If C is known, R is known, and omega naught is not known, we can find the qualitative factor Q. And many such relationships and can be found, say in this case, if C is less and R is less, Q will be more. If C and R are more, then Q will be less. And if omega naught is more, then Q will be less. If omega naught is less, Q will be more. In this way, we can find n number of derivations. But main mathematical expression is this, and from there you can find out many conclusions and many answers. Many questions can be asked on these conclusions. So read it carefully and do the implementation, solve various types of problems. Now let us go to the book. So we have already derived this these equations. Again, we have also derived these equations. So everything is derived and explained line by line and hidden concept behind this. Now let us solve one of the examples. Example 7.6, a resistor of 200 ohm. So resistor is given and a capacitor of 15 microfarad capacitor is given, connected in series of 220 volt, source is given, and omega, that is 50 hertz AC source. is also given. A. Calculate the current in the circuit. B. Calculate the voltage RMS across the resistor and capacitor. The algebraic sum of the voltage is more than source voltage. Is the algebraic sum of these voltages more than the source voltage? If yes, resolve the paradox. Fine. Write whatever is given in the question. So resistance is given, capacitance capacitance of the capacitor is given, voltage we have converted into SI unit. So voltage is given, frequency is given. Now, in order to calculate the current, we need to the impedance of the circuit. So Z is equal to R square minus XC square. Just XC we can write 2 pi nu C, that is, and put the value. So put the value of R, put the value of pi nu C, everything is given to you. Just solve it, we get the value of the impedance Z. Therefore, the current in the circuit is I is equal to V by Z. Remember, Ohm's law, I is equal to V by R. So, I for impedance, just V by Z. Instead of R, just replace it by Z. So, no need to remember a new formula, just remember this concept. So, the I we got since B part, since the current is same throughout the circuit, we have VR is equal to IR. So V is equal to IR, that is Ohm's law. Just put the value of I and R, we get the voltage through the resistance. Again, VC is equal to IXC, same way, Ohm's law. So I put the value of I, put the value of XC, we get this much voltage. The algebraic sum of the two voltage VR and VC is add it, this two, add it, you get 311.3 volt, which is more than the source voltage 220 volt. To resolve this? How to resolve this paradox? As we have learnt in text that two voltages are not in the same phase, therefore they cannot be added like ordinary numbers. The two voltages are out of phase by 90 degree. Therefore, the total of this voltage must be obtained using Pythagoras theorem. That is, VRC is equal to under root VR square plus VC square, that is 220 volt. Put the value of VR and VC and we get 220 volt. Thus, if the phase difference between the two voltage is properly taken into account, the total voltage across the circuit, across the resistor and capacitor is equal to the voltage of the source. So they are equal, not much. So that's it for today. So today basically, let us recapitulate. Today basically we have studied about resonance and the sharpness. We have derived the equations. We have done quality factor, etc. And last we have done a numerical based on that. So in the next class, we'll go through 7.7 power in AC circuit, the power factor. Before we end our today's class, please, we request you to subscribe our channel if you have not done yet. If you have not subscribed yet, please like our videos and share our videos among your friends and relatives so that we can grow, our channel can grow, and with our channel you will get more and more benefit, more and more good, better quality, better content video will be published. So it We ourselves, with your help, can make it possible. Thank you very much for supporting us and watching our videos. Please keep watching and please communicate with us. And if possible, please like our videos. Thank you very much.